Hello flow creators, welcome to this channel of mine, and today I'm going to be introducing you to a nice little utility library I have discovered over Twitter, which is called React.js Form. And let me just show you through a React app how it simplifies the modern workflow that is built around composing and making up entire forms in React applications. So just let's go through it. So this is the GitHub repo for the TypeScript form library, and some GIF is provided here for you to see how it simplifies your workflow. And out of the box, it ships with several features, like it generates your type-safe forms with the Jod schemas. It eliminates repetitive JSX, which is kind of really going to be a handy thing for you when you have a lot of JSX markup to maintain around form building and stuff. And then you get full type-safe props, and it's totally headless, so no opinion around the design systems or the visual component libraries that you use to build your forms. It's all logic, which is really a nice addition. And then definitely, since it's around taking the boilerplate out of your React form building experience, you get a really simplified structure which is more maintainable for you. And it's as you can see, it's a tiny library, just around 3 KB and 100% test coverage. Doesn't look like a nice thing to add to your repertoire of skills or the front end skills. So let's start. I have a React app already prepared for you. I'll just kind of open it up, and we'll see how we add this library and how to build a very simple form around the React.js form constructs. So let me just show you what I've created for you. So this is a typical React app, just an app. We have a form already created. And the form is simply the form built using React hook form. A React hook form, if you go through the documentation of the React hook form, you'd see that it lets you kind of very declaratively create form elements, and then register them with the type of the validation you'd like to perform with your form fields and other similar use cases that you might have around your form elements. The basic necessity for this project to run is basically you need to have a TypeScript which is kind of upgraded to version 4.9, and then when you're creating a React app, you use the TypeScript template, and post you are done with creating the boilerplate React app, just have this dependencies installed. These are like peer dependency, which are very much required for this utility library to run. First, definitely it would be Zod, because Zod is the baseline foundation on which this library is built. And then the React hook form, and because React hook forms lets you build the form, and Zod lets you build the schemas, and then you connect these two pieces to build a really type-safe form. And hook form resolvers, it's again a library that lets you kind of define resolvers for the form you're creating through React hook form. If I can walk you through the npm page, you can see that the hook form resolvers is a nice library built around providing the schema for your form in a really declarative manner out of the box. It ships with the support of other type safe validation libraries and non-type safe validation libraries also. Like you have the support for Yup out of the box, you have support for Zod out of the box, and then you have support for Superstruct out of the box. So it currently works with almost all of the popular schema libraries you have available in the npm ecosystem. The version we are going to be using for this project will be based around the Zod version. So let's go back to the code again, and let's see how this entire thing works. Do make sure that you have hook form resolvers installed, you have a React hook form installed, and you have Zod installed. Without this is not going to work, definitely. And then once everything is installed, you have TS React form also available to you. So the typical makeup of a form in a React app when you're using a React hook form looks like this. We have already went through this. And the outcome of this app is something like this. A very basic form where you can type anything, say my name is Aftab, and then say that my age is around 30 row. Okay, so that's how a basic form is created. Now, when you're using a React TS form specifically, and that too with Zord, if you're new to Zord, the way you define such forms is you basically create a resolver. A resolver is something that lets you define the shape of the data that your form is capable of collecting, and then also define validations that accompany your form fields, so that you can create a structure that is more organized, that is more maintainable. Once you have this created, say that the Zord resolver is imported out of the resolver's Zord library. You have Zord as the primary namespace available to you, and you have this schema which defines the shape of your form data available. This is the baseline structure that needs to be there, so that you can plug it to the your form. And once you have this available, what you need to do is basically you come here and you do something like resolver, and you provide Zord resolver, and then in the Zord resolver you just provide that type of the schema. Once you have this schema available, you can feel that your form is now wired with the schema validation as well as the proper validation messages. So if I run this example, you'll see in this code base, let me just type this again. I just exited of this one. Let me just reboot this. The development server is starting, taking a while to start, but now it's available. I can come in and type in things again. Or say you have something like this, it's all working. If I say don't provide Aftab, then the validation pops in, right? Everything is working with the nice validation. Where the React TS form library comes in play is once you have the shape defined, you can come and you can do something like this. Import TS React form out of the module that you have stored, and use TS controller, which is the primary construct you would be using to atomically work with the form elements or form controls you're working with. Because a custom form field is a basic kind of demand that this library is having with you, that you provide, so that you can more flexibly work with atomic elements, because it works in the space of auto-generating form elements. So just like a template, you need a schema or a structure or a shape that can be repeated with the different form elements. So with text field, what you do is basically you'll create a basic React component, and within that you do use TS controller, and defines the type of the data that it contains. You'll have the field available to you, and the error, around which you can just collect the field value to show the field values, and to dynamically keep updating the field values as your user is typing. And then on change, definitely, since it's a control component, you do this to update the values. And if you have an error, the way to show errors is just kind of access the error message and show it, right? So you basically take these out of here and you place it inside in a really reusable format, so that you can repeat this thing again and again. If you have, say, another field available, what you would basically do is you'll just duplicate this structure, and you do something like, say, number field. Okay, now you have two fields, text field and number field, that can represent at least this basic example we have created, right? Where now the TS React form comes in mix is, now you can have a structure here, which is something which can be defined something like cost form struct, define it in array format. Okay. And within an array, you define individual fields again with a array format. And here you define something like Z string, the type with which you want your form control to apply is what will provide as the first parameter to this, array of arguments. And after that, you provide the form field that you have specifically created to work with a similar type. Once you have this, since we are having another field, which is age, which is a numeric field, we can just duplicate this structure and we can do this number field and define it as a cost, right? Once you have this structure available, the way to go about creating your own version of a really type safe and repeatable and highly maintainable form is to create something like cost, let's call it TS form. And here you do something like create TS form, and within the create TS form, you basically take this form structure and you place it here. Here's your final TS form. And once you have this TS form, the way to go about this would be to now use this TS form instead of the form element that you are working with so far and place it over here. Like you can just copy this and you can place TS form here and a TS form here. And then you can just get rid of this entirely, right? TS form, everything's just gone now. The essential thing to bind this with your schema would be to just use the schema that you have created earlier for the text field and the number field here, like name and age, which define the shape of the data your form will collect, and then put it over here, right? Another thing is that this library expects is on render. Let me come to this. Once I have this, I think I have omitted this. So let's put this back, which is the job resolver. And within the job resolver, you just put the schema. Okay. This is the entirety of your, now you can get rid of this also. You can get rid of this also, just as necessary here. Render after is the element that will work like the CTA, the call to action, or the submit button of your form. Just put something like which is button type submit, and then just submit. This is not necessary. It can be just this. Now, since we have this structure, what we can do now is we can get rid of this also. Let's just make it a self-closing tag. We have this render after and everything. This is also kind of unnecessary now. Get rid of this. Use form needs to be inside your form element. You have this resolver defined with a schema on submit. We can take it one step further and we can basically infer the type of the data which is kind of made available through a Zordo schema, and it's just a schema at this point. Once you have this available, you can have type safe properties available to you here. And let's just look at the final view of the component that we have available to us. Let's just open the browser and then let's just look at our app. Just refresh, submit, required, it's working fine. Oh, put a name, Aftab, submit. Let's put 32, it's just a number, but this received a string. It might have to do with the type that we have created as a number field here. Oh, and since this was a number field, you'd be required a bit of typecasting here. So provide the number as a type here. And while you are assigning the value, just change it to a numeric value. And once you have this, the error from your form fields will go away. And let's just look at this. It's all working. You provide this expected number, receive NaN, which is problematic. And then if you do this, you receive this, then Aftab, and then 32, it's gone. Submit, your form is working. So I try to cover just the basic features that the React.js form provides. And in a future video, I definitely dive a bit more into it and we'll cover more advanced scenarios, more form elements, and play with a UI library and see how this library greatly simplifies your modern React development work. Hope you liked the video. If you like the video, just do like the video, and definitely looking forward to ship more awesome content in future videos. Bye bye.